A sequence is numbers that can be used, or a sequence is a list of numbers that follow a rule. And a specific sequence that we're going to look at today is examined by these first two. Right? What's different about those first two?
You add to and subtract.
But it's the same amount you're adding or subtracting each time, right? And since we can express subtraction as addition, right? Subtracting 3 is the same as adding -3, right? These other two, we're multiplying by 3 here, and we're squaring the terms there. So these involve addition, and these involve something else, right? This involves multiplication, and this involves an exponent. There's a rule that is involved, but it's that. Wait, what?
No, I read it wrong.
Okay. So an arithmetic sequence is a sequence that has a constant difference between two consecutive terms. All right, and that's called the common difference. All right, so a common difference there. All right, so an arithmetic sequence is a sequence that has a constant difference between two consecutive terms. What do we mean by consecutive terms? Terms that are right next to each other, right? A term and a term that comes after it, or a term and a term that came before it. Those are consecutive terms in the sequence. All right, so if we have a little bit closer look at those two, the first two sequences on the previous page. Are y'all okay with this? Can I move forward? The first sequence was 1, 3, 5, 7. That's the odd integers, right? And then plus 2 each time. So in this sequence, the common difference is positive 2. And in the second sequence that we looked at, and you guys all nailed it, we're subtracting 3 each time. The common difference is -3. Because we're adding -3 each time or subtracting 3 each time. And that's going to be true all the way through the sequence. These are called arithmetic sequences, and they have that specific pattern that there's a common difference between any two consecutive terms. Okay? Now, determine if this sequence is an arithmetic sequence. If yes, find the common difference and the next two terms. Okay? It's going to be important to kind of stay on top of the definitions and the things as we go through this lesson. Is this an arithmetic sequence or not?
Yes.
It is, right? What's the common difference? Plus 5. So what the next two terms would be, what? 27 and 32 would be the next two terms. All right? So it is an arithmetic sequence. The difference or common difference is 5, and the next two terms would be 27 and 32. Now what we're going to work toward here is finding a rule or writing a rule that would help us to find the 17th term without listing 17 terms in the sequence. Okay, so that's what we're headed toward. Write a rule so we can jump straight to the nth term, the 57th term, the 60th term of the sequence. Okay? And being able to write that rule has a lot of applications in computer programming. If you're going to write a program that does something over and over and over in succession, a sequence of things, a sequence of events, then there's numerical rules. It all comes down to math when you're doing computer programming. All right? Now, here's another example. Is this sequence an arithmetic sequence? If yes, find the common difference in the next two terms.
Multiply by 2.
All right? Is that an arithmetic sequence?
Yes. No.
What is an arithmetic sequence?
A sequence that has
A common difference, right? All right. Common difference. What's 6 minus 3?
3.
What's 12 minus 6?
6.
Is that common? No. It's different, right? Now, is this a sequence? Yes. But it's not an arithmetic sequence. Okay? This is an exponential sequence. Right? We could write, but we're not going to do that now. Okay? This is 3 times 1, right? The first term is 3 times 1. This is 3 times 2, 3 times 4, 3 times 8. So the next term would be 3 times 16, right? Because this is 2 to the 0, 2 to the first, 2 squared, 2 cubed, 2 to the fourth, the powers of 2, right? So this is an exponential sequence that deals with powers of 2, right? This is 3 times 2 to the n power. Actually, n minus 1 because we start with 2 to the 0. So the first term is 3 times 2 to the 1 minus 1. 2 to the 0, that's 3. Okay? So that's how, this is an exponential sequence. It is a sequence of terms because it follows a rule. All right? Now, let's get some notation here. An arithmetic sequence. The first term of the sequence is denoted as A. How would you read that? A sub 1. Subscript 1 or A sub 1. You can just say sub 1. That tells you that 1 is subscripted. Okay? The second term is A sub 2. The third term, A sub 3. The nth term would be denoted as A sub n. So if I wanted the 15th term, that's A sub 15. Okay? Now, the term preceding A sub n would be denoted as A sub n minus 1. Right? So, for example, if n is 6, the term preceding a to the 6th is a to the 6th minus 1, which is a to the 5th. Okay, and that's going to be important as we kind of build what is called the recursive formula. And we're not going to use the recursive formula a lot. All right? I just don't love the recursive formula. No, it's not as useful for finding the nth term as the other rule that we'll write here in just a little bit. Okay? All right, but let's have a look at, you don't need to write this down, so you can put your pencils down and just have a look. So this table gives us the term of the term number in the sequence. So the first term, second term, third term, fourth term, fifth term, nth term. Okay? Now, let's have a look at what it's telling us here. It looks like our first term in this sequence is 7, right? The second term is 7 plus 4. What does that tell us? Plus 4 is my common difference, right? This D equals 4. Common difference is 4. And then the next term takes the second term, which was 7 plus 4, and does what? Adds 4 again. And the next one takes that term and adds 4 again. And the next one is that term and adds 4 again. So the nth term is the n minus 1 term plus 4. Okay? And then so the recursive formula that we get from this is that a sub n is equal to a sub n minus 1 plus the common difference. Now, let's just kind of break that down and put it into everyday language. Right? Any term is the term that came before it plus the common difference. Duh, right? Now, why is this term not useful for, say, finding the 100th term? The 100th term would be equal to what? The 99th term plus the common difference. Because if we're going to find the 100th term, you have to go all the way up to the 99th term to get there, right? So why not just go one more in your making of your list? But what this kind of helps you to do is this recursive formula, this pattern. What you do with the nth term is the previous term plus whatever the common difference is. Okay? Not super helpful, right? But it just kind of gives you an idea of what the sequence looks like. Okay? Now, so this is the recursive formula. Again, you don't even really need to write this down because it's kind of duh. Right? The nth term of an arithmetic sequence is equal to the term before it plus the common difference. Right? That's why I say it's kind of duh. because it's, the 19th term would be the 18th term plus the common difference, whatever the common difference is. So if you already have the 19th term, why not just add and not even really think in terms of what this formula? So this recursive formula is not a real useful formula for us. Right. It's much, much better to write a rule that'll give you the nth term of the sequence that you can just plug the number into and go. Kind of like a function works, right? All right. So let's have a look at how that might look after we look at a few of these. Use a recursive formula. What is a recursive formula? It means to find a term, you take the previous term and add a number to it. If the first term, a sub 1, that's the first term in the arithmetic sequence is -2, and the common difference is 7, we want 4 terms. What would they be? -2, 5, 12, and 19. So that's using the recursive idea that each term is 7 more than the one that was before it. Okay, what about this next one? First 4 terms of an arithmetic sequence where the first term, a sub 1, boo, is equal to, I went back too far. No, I'm lost. Somebody help me, please. All right, there we go. The first term is, a sub 1 is -3. The common difference is 4. So what would the next term be? 1, 5, 9. Okay? Really a simple concept. Now, let's see if we can, this next part is the part that gets a little confusing. Defining a rule or an equation for finding any term in an arithmetic sequence. We want to be able to find any term. That's what we're looking for right there. So let's look at the rule a little bit different. Let's just say, for example, that the first term in our arithmetic sequence, a sub 1 is equal to 7, and it looks like, again, we're going to end with a common difference of 4, right? So the next term we would add 2 4s. The next term adds 3 4s. The next term adds 4 4s. Right? All right, so look at the pattern. The second term adds how many 4s?
2.
Second term adds 1 4. The third term adds 2 4s. The fourth term adds 3 4s. The fifth term adds 4 4s. The nth term adds n minus 1 4s. Okay, so the pattern is that the third term takes the first term and adds 2 of the 4s. Right? Okay. 1 less than this. The fourth term takes the first term and adds how many? 3, which is 1 less than 4. All right. The fifth term takes the first term and adds 4 terms, right? So the nth term takes the first term and adds n minus 1 4s. So the recursive rule that we get, not recursive, the arithmetic sequence, the rule for an arithmetic sequence is that the nth term is equal to the first term plus n minus 1 times the common difference.
Whoa.
Yeah, so if we went back to that very first arithmetic sequence, what was it? Y'all remember? It was just the odd numbers, right? The nth term of that sequence is the first term plus n minus 1 times the common difference, which is 2. So we could find the 150th term in that sequence. The 150th odd integer is 1 plus 149 times 2. Okay? All right? So that's how this thing works. And this is the formula that we're going to dance with right here. And we need to be able to kind of interpret what it means. If we can interpret what it means and remember it, then it's going to be easier to memorize that way. All right, so finding the nth term of an arithmetic sequence. Let's put this in words. A sub n represents the nth term. The nth term is, there's my equal sign. What's a sub 1 represent? The first term plus n minus 1 times, what is d? The common difference. Now, I don't know any way to help you learn that other than to memorize it. I mean, it's one of those things you commit to memory. We'll put a little teeth behind it in just a second, but the nth term is the first term plus n minus 1 times the common difference. Okay? You got that, Charlie? Charles? All right. Now this is giving us a rule. Use the rule a sub n equals 6 plus n minus 1 times 2 to find the fourth term and the 11th term of the sequence.
Okay, 6.
All right. Tell me about this sequence. What do we know about the sequence just from looking at this rule? What's the first term of the sequence? 6. What's the common difference? 2. So 6, 8, 10, 12, and we could do, we know what it's going to look like, but using the rule, a sub 4 equals 6 plus 4 minus 1 is 3 times 2. That's 12.
Oh.
Okay. The 11th term of the sequence is 6 plus 11 minus 1 times 2. 26. Right. The 76th term of the sequence is 6 plus 76 minus 1 times 2. That's 156. Okay? So you can, right, this rule is extremely useful for generating sequences for as long as you needed to generate a sequence of numbers. Okay? Okay? And you would use this rule like if you were doing some type of graphic art and you wanted every second pixel on the line to be a certain color, or every 10th pixel on the line to be a certain color. So you could do graphics programming and, you know, create a pattern. There's a lot of the things that we draw and look at are pattern related, right? The American flag. I can remember when I was in school, high school, computers were pretty new, mind you. We had to do a graphics program. We had to write a graphics program that would draw the American flag. And yeah, it was cool. But you had to use a lot of sequences, and because, you know, the stars are here, you have to place things right and tell it what pixels to color which color, and you know, and you know, this type of programming and this type of thinking is important. Right, Jack?
That's what he would use. That's a fact, Jack.
Jack's Sleepy Jack today. We call him Sleepy Jack. All right, here's another one. Now this one says write an equation or write a rule and use it to find the 10th term of this sequence. All right, we're going to go back to our formula. Right, the formula which gives us a rule for an arithmetic sequence. This is arithmetic, right? Because we need to establish that first of all. A sub n equals, it's equal to the first term of the sequence plus n minus 1 times the common difference. So a sub n in this case would equal, what's the first term? 3 plus n minus 1 times 8. That's the, write an equation. Bam. I just did it. That's the equation. Now I want to use that equation to find the 10th term. A sub 10 equals 3 plus 9 times 8. 75. So A sub 10, 75.
This is an easy lesson. I don't know if those people are talking about it being hard.
Well, maybe I'm teaching it better this period than I did last period. And plus, you came in here expecting something to be difficult, so what are you doing? Focusing. Yes. Imagine if you're just out of lunch and thinking about everything that just happened in a lunchroom instead of fifth period. Challenging. Fifth period, you guys are challenging. Step it up. Be more mature. Jay Hinton. All right.
Oh, dang.
Okay. Try this one on your own. Write an equation and find the 10th term of the sequence. Not sequences. Just sequence.
Oh. Oh my.
Can we still
Does the
use
answer have to
the...
be a fraction?
Most likely will. Yeah, I mean, every once in a while you might have a whole number that jumps into the sequence, but
No, no, like, does the answer, okay, well, if they did it in
I found
fractions, you
it.
have to leave it in fractions.
Is it the 10th term?
yeah, I'd leave it in fractions, yeah. Mhm.
So we leave
So,
I don't know how you would do it without fractions, to be honest. Well, I can think of a way maybe you could do this without fractions. Yeah.
oh,
Hi.
hi.
Crap.
I keep hearing the door. I did too. I heard that.
Still,
Yep.
Um,
All right, so we're going to use our formula for an arithmetic sequence. First term plus n minus 1 times the common difference.
I finished.
ooh,
All right? All right. You got the equation, Jack? What's the equation?
A, yeah,
A sub n
A sub n
equals
1/4,
1/4. Beautiful. First term plus,
4 minus 1.
no 4 there. This is the nth term in there. Times the common difference, which is what? 2/4. Why leave it as 2/4?
so it's easier to do it like add it.
So you automatically have a common denominator, right?
Changed it and you didn't have to change it back anyway.
That's right. So the 10th term then would be a sub 10 equals. Now, the reason I wanted that in there, Jack, is because we want to write an equation, right? That's part of it. And use the equation. Here's the equation. There's the first part of the answer. Then use the equation to find the 10th term. The 10th term would be 1/4 plus 9 times 2/4. That's 18/4 plus 1/4, which is 19/4.
And this is easy. Yeah, that's what I got.
I thought it was going to be hard, but then I thought about it.
No.
He doesn't like mixed numbers.
Well, I mean, do we have mixed numbers in the sequence? I mean, let's follow the pattern of the sequence, right? Now, let's have a look at one other way that you could write this. What is represented in the numerators here?
I saw that.
It's an odd number, which is a sequence, right? So we could also write this as a sub n equals 1 plus n minus 1 times 2 over 4.
That looks horrifying.
It's not. It's the same thing, right? Because how many terms are in the numerator here?
And then you just
There's
put
2 terms. Each one of them is over 4. This is the same as 1/4 plus n minus 1 times 2/4. It's the same thing.
Easier. Like the top thing.
It does look a little easier. Because if you put 10 in here now, if you put 10 in here, you get 10. That's 10.
Yeah, so
That's,
easier.
it's
Plug
19
in the end.
over
But I
4.
feel like in some cases it would not be.
Yeah.
That's true.
All right. So that's another way that you could write this rule just using the numerator, because the denominator is boring. It's just 4, right? So these are the odd integers over 4. All right. Okay. So I think, is that it? Last one. The first table at a reception will seat 9 guests, while each additional table will seat 6 more guests. Right? Write a rule to model the situation. Now, does this describe an arithmetic sequence?
Yes.
Yeah, because you can
Yes.
subtract.
Maybe.
What are we doing?
No,
Adding
no.
You're adding 6
You're
more.
adding 6 every time you add a
Yeah.
table, right? So it does, because we're increasing by 6 each time. So my first table seats 9 people, and then each additional table has a common difference of 6. Use the rule to see how many 10 tables will seat. That's 9 plus 10 minus 1 is 9 times 6. That's 63 people.
What?
All right? You good, Charlie? Now, this is something that if you didn't practice it now, you'd be just as foreign to you in a couple of days as, as if you had never seen it before. Very important to practice this concept. But before we move, and this is not something that I want you to necessarily apply while we're doing this lesson, but I need to point something out to you. What would we get if we simplified this expression? Simplify the rule. Get rid of like terms and get rid of parentheses and combine like terms.
15 plus 9 minus 1.
Not 15.
6n minus 6.
6n minus 6 plus 9
Plus 9.
is 6n plus 3. So a sub n is 6n plus 3. What kind of equation is this?
Wait.
What if my variable here was x?
Slope.
It's mx plus b, right?
Fancy.
Okay. So this is describing a linear relationship with a slope of 6. Now, we've already looked at this in table form. If you look at a linear relationship, every time x increases by 1, y increases by whatever the slope is, whatever the rate of change is. Okay? So, arithmetic sequences are linear relationships. We could talk about the slope being the rate of change or the common difference, because the slope is the common difference between two successive integral points on a line, right? To go from 1 to 2, if the slope is 2, the y value is going to increase by 2 every time you increase by 1. All right, so I want you to see a relationship here between, again, that old faithful thing that you guys did a lot last year, y equals mx plus b. B is the y-intercept, which is the ground 0, right? X is 0, that's the y-intercept. It's the starting point, it's the first term, so to speak. Okay, and you go from there. All right, homework. Page 214, A through F, and 1 through 15, and 17 through 29, odd.